All right, folks, you'll probably be happy to know that this is the last topic you're going to learn for this chapter and the last topic you're going to learn for the year. So I think I can hear you all screaming, yes, 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 hooray, and pounding on the table. Anyway, first of all, I want to let you know that all of these slides that I'm going over here to show you how to do molarity problems are going to be posted in the solutions resource folder as molarity sample problems so that you can refer to those when I ask you to do the homework where you actually solve molarity sample problems. Now, in a previous lesson, we talked about one way to oh my God. In a previous lesson, we talked about one way to express the concentration of a solution, and that was as percent concentration. Another way to express it is using a term called molarity. Molarity is defined as the number of moles of solute, that's what you dissolve, over the liters of solution or the mixture of solute and solvent that you create. So that's what it is in terms of words. In terms of symbols, capital M equals lowercase n, as in Nancy, stands for moles, and divided by capital V stands for volume. So for the first example, we're told that we have so many moles of sulfuric acid in 0.1 liters of solution. What is the molarity? So we're going to be using our formula, M equals N over V. So this one is pretty straightforward. I plug in my number of moles. I divide it by my number of liters. And my calculator says it's 2.50. Now, every numerical answer in chemistry has a unit. So we need to put a unit on our answer. And the unit can be written one of two ways. You can use the actual units, moles per liter, or you can simply represent it by a capital M. That is the standard way that most solutions would be labeled. It would not be labeled 2.50 mol/L. It would be labeled 2.50 capital M. In literature, the M would be italicized, but we're not going to worry about that. Now, I'm not going to go crazy about SIGs, but each one has 3. Please don't round it to 2.5. Well, 2.5, you could round this one, but please don't round it to 3. Give a few decimal places so we can actually see what the true value is. Next example. Now we are given liters of solution and the molarity of the solution, and we're asked to find the moles. Going to start with our same equation, M equals N over V. Plug in what we know, and now we are solving for the number of moles. So we have to rearrange our equation to get N by itself. So if I multiply both sides by 0.500, this is what I get. If you like, you might want to make a note that this is the version of the formula you would use if you're solving for moles. So either plug it in and rearrange it yourself or make a note of this formula on how to solve for moles. Plug that into my calculator, and I get 0.0750. Please don't round it to 0.08, at least say 0.075. And our unit for this is moles. That's what we're solving for. Example number 3. We are given molarity in moles, and now we need to solve for volume. So we plug in our numbers. Now we're solving for volume, which is in the denominator. And a lot of students struggle when they have to solve for X, V, P, whatever it might be, when it's in the denominator. So I've taught you other times during the year, the best thing to do is to cross multiply. So 0.600 times V equals 0.125 by multiplied by an invisible 1. So I've cross multiplied. To get V by itself, I must divide both sides by 0.600. So again, you can start with the original formula, plug it in, rearrange, or make a note that when you're solving for volume, it's moles over molarity or lowercase n over capital M. Put the numbers in your calculator and you get, whoops, gotta go back. It was kind of covered up on me. What? No, don't panic. Don't panic. So we put that in our calculator, and V equals 0.208. Again, don't just round it to 0.2. Give me about 3 decimal places. One more sample problem. How many grams of potassium nitrate are needed to prepare 500 ml of a 0.7500 molar solution? Well, we're going to use our same equation, M equals N over V, but got a couple issues here. First of all, we are given the volume in milliliters, but I cannot plug milliliters into the equation. I have to change it to liters. Second, we are asked how many grams of KNO3. Well, the equation that we use, N is not the number of grams, it's the number of moles. So once we determine the number of moles, we're going to have to convert that number to grams using molar mass. So we'll start by converting milliliters to liters based on the fact that 1 liter contains 1,000 milliliters. Now I can plug in my molarity and I can plug in my volume. When I solve for N, this is what I get. And again, I told you if you want to remember this form of the equation, when I'm solving for moles, it's molarity times volume. When we do the calculation, we get 0.375 moles. Now, students, may tend to stop here and say, oh, it's 0.375 grams, but it's not. The equation doesn't give you grams, it gives you moles. So earlier in the year, we learned that we can convert between moles and grams and moles, using the molar mass of the compound. The compound is KNO3. So I need to refer to my periodic table and determine the molar mass of KNO3. I determine that by accounting for the mass of 1 gram of, 1 potassium, 1 nitrogen, and 3 oxygens. So when I take those masses and add them together, I get 101.1. So there are 101.1 grams of KNO3 in every mole. So moles, grams goes on top, moles goes on the bottom. I multiply, and my final answer is that we would need 37.9 grams of KNO3. And that's a pretty practical problem, because if I want to make a solution, just determining how many moles are needed is not sufficient, because my scales don't weigh in moles, they weigh in grams. So realistically, once I determined the number of moles, I would then have to determine the number of grams before I could make the solution. So again, these slides, all of these slides, all these samples, I am posting in a PowerPoint called Molarity Sample Problems. So you don't have to rewatch the video. You can just look at the slides, and if you use the slides, you should be able to solve similar problems following the steps that I used in the slides. Okay, so all you have for today's homework is this Edpuzzle. Remember, hopefully you've answered the questions correctly by paying attention and looking at the screen to help you with the answers. So that is the only thing for today. And tomorrow's assignment will be molarity problems. Okay, folks, we're almost there. A couple more days to go. The last date for an assignment to be due is Monday, June 8th. So hang in there a little bit longer.